Why earth and heaven trembled because of the black and sinister arts of an Irish writer in foreign parts. He sent me a book 10 years ago. I read it 100 times or so, backwards and forwards, down and up, through both the ends of a telescope. So that was written by James Joyce in disgust that another printer had let him down and he couldn't get his book, Dubliners, published. It was on the boat leaving Dublin for the last time. But of course, we're not in disgust tonight. We're here for a wonderful celebration of a convergence of science and literature through the works of James Joyce. And I'm very grateful that DIAS, the Dublin Institute of Advanced Studies, will once again be hosting this, I guess it's now an annual event, the Heaventree of Stars, which of course was the brainchild of the wonderful Des Gunning a number of years ago. And myself and Luke Drury and Des came up with this wonderful plan. Unfortunately, we can't be in Dunsink this evening, but I urge you all to go out to Dunsink as soon as it opens again. It is a wonderful, wonderful space and a great venue for all these occasions. So my name is Starina Gallaher, and this year I have been promoted from lowly performer to acting director of the James Joyce Centre. So it's a wonderful honour for me to be representing the James Joyce Centre in collaboration with DIAS. But before, Des Gunning just asked me to think about a few people that we have lost this year in the science and the Joyce community. Professor Denis O'Sullivan passed away in February, and he was one of the pioneering figures of the Academy and of Irish astrophysics. He was the first Irish scientist to examine a moon rock in 1972, which of course we all know was a very important year, the year I was born, and a pioneer of the Irish space research and a mentor to many here. The Dublin Joyce world has lost Jerry O'Flaherty, who was the first Irish member of the International James Joyce Foundation, who actually his conversations on Ulysses with Fritz Zen will be made available this year in the special RTE digital weekend, which is happening for in conjunction with RTE in Bloomsday. We also lost Nolene O'Donoghue, who is no less a Joyce scholar and enthusiast than her husband, Terence Killeen, who is a research scholar at the James Joyce Centre. We lost Ulick O'Connor, too, who was the last remaining survivor of the first Bloomsday celebration in 1954. And of course, James Joyce's grandson, his only grandson, Stephen Joyce, who passed away in January. And of course, perhaps we should remember that today is the funeral of George Floyd, whose dreadful circumstances of his death have been a wake-up call for us all in this terrestrial world. But today is a celebration of 80 years of DIAS. So a big happy birthday this month to DIAS, and incredible that all the work that has been done and carried out over the last 80 years. And of course, it's the start of our Bloomsday celebrations and a celebration of Leopold Bloom, who is in fact, for me, the archetypal citizen scientist. His intense curiosity about the world, about us all, about mankind, about the world we live in, and about the moon and the stars and the universe that surrounds us. He's constantly asking questions throughout Ulysses. He's constantly asking us to push our minds and search to answer questions about how we live our lives. And tonight we are lucky enough to maybe get a few of those answers, as we have three wonderful scientists giving presentations. We have Director of Dunsink, Professor Peter Gallaher. We have Owen Gill, and we have our own veteran of the Heaventree of Stars, Luke Drury. And we're very privileged tonight to have some wonderful performances from my wonderful colleague, Sinead Murphy. And especially this evening, we need to welcome Barry McGovern, who will do some readings. Now, unfortunately, the bandwidth in the James Joyce Centre was so appalling that we've had to record some of these pieces for you, but I don't think they'll be any less special. So before we start, I had the wonderful opportunity to do a rehearsal for this evening's meeting with Peter Gallaher, and we both have the same book in our hands, which is The Story of the Heavens by Sir Robert Ball, which is, of course, the book that Leopold Bloom is reading. So if I may start this evening in honour of Peter Gallaher, who I know is very much involved in solar physics. We'll have a little extract from Ulysses and thinking about the sun and Leopold Bloom's examining of parallax in the sun. Mr. Bloom moved forward, raising his troubled eyes. After one time ball on the ballast offices down, Dunsink time. Fascinating little book that is of Sir Robert Ball's. Parallax. I never exactly understood. There's a priest, I could ask him. It's Greek, parallel, parallax. Metempsychosis, she called it, till I told her about the transmigration. Oh, rocks! He faced about and, standing between the awnings, held out his right hand at arm's length towards the sun. Wanted to try that often, yes, completely. The tip of his little finger blotted out the sun's disk. Must be the focus where the rays cross. If I had black glasses, interesting. There was a lot of talk about those sunspots when we were in Lombard Street West, looking up from the back garden. Terrific explosions they are. There will be a total eclipse this year, autumn sometime. Now that I come to think of it, that ball falls at Greenwich time. It's the clock is worked by an electric wire from Dunsink. Must go out there some first Saturday of the month. If I could get an introduction to Professor Joly or learn something about his family, that would do. Men always feel complimented. Flattery were least expected. Nobleman proud to be descended from some king's mistress, his foremother. Lay it on with a trowel. Cap in hand goes through the land. Not go in and blurt out what you know you're not to. What's parallax? Show this gentleman the door. Ah, his hand fell to his side again. Ah, never know anything about it. Waste of time. Gas balls spinning about, crossing each other, passing. Same old ding-dong always. Gas, then solid, then world, then cold, then dead shell sifting around frozen rock like that pineapple rock. The moon. Must be a new moon out, she said. I believe there is. So let me now introduce, from one Gallaher to another, Professor Peter Gallaher, Director of Dunsink. Thank you, Peter.
Thank you for that lovely introduction, and welcome everybody to Dunsink Observatory here in West Dublin. And Starina, can you hear me okay? Great. Well, behind me is this magnificent building that is referred to in Joyce's writings, and also the location where Sir Robert Ball wrote that beautiful little blue book about the stars. And the observatory itself really was set up for doing one or two specific things. One of them was looking at time and working out what local time was here in Dublin and setting it for the whole of Ireland. And I still like to use the expression Dunsink time when I'm asking people for meetings. There's also, you can see a dome above me, and that dome is where the original telescope was. And then as we swing around here, we've got about 12 acres of land. Please do come and visit sometime. There's also a lovely dome, again from the, well, this one's from the 1800s. The dome itself was built in the 1860s. But I'm going to bring you on a tour inside the observatory and talk about some of the measurements that were made here and how they related to some of Bloom's daily life. Okay, so off we go. I'm going to turn the camera around and give you a bird's eye view of walking into the observatory. Eventually, when I press the button right. Here we go. Well, there's the gravel path up to the observatory. And Bloom never did make it out to the observatory, unfortunately, but if he had done so, I'm sure he would have knocked on the door and been welcomed in by Professor Joly. And Professor Joly would have spent his whole working life, as did the other astronomers who worked here, working on problems about distances to the stars, trying to understand exactly what the time was in Dublin. Looking at the brightness of stars and the ages of stars was another pastime. Probably the greatest astronomer that we had was Sir William Rowan Hamilton, and here he is with his wife on the Royal Canal, and he's actually sketching the first piece of astronomical or mathematical graffiti, sketching on Broome Bridge, and he's sketching these equations called quaternions, and he became world famous for that. I guess at the time when Joyce was growing up, the astronomer that was located here, and that was the Astronomer Royal, was a gentleman called Sir Robert Ball, and here he is, Sir Robert Ball, very jovial looking man, and he wrote popular science books, and he also did some really interesting science as well. He worked on a theory of screws, was one of the books that he wrote. But the book that Bloom bought on Liffey Street in Ulysses was this beautiful blue book. And within that book, there are plenty of stories about how we measure the distances to stars and other exotic thoughts that fascinated the mind of Bloom. And I'll just read the first little bit of the book. The story of the heavens is the title of our book. We have indeed a wondrous story to narrate, and could we tell it adequately, it would provide of boundless interest and of exquisite beauty. It leads to the contemplation of grand phenomena in nature and great achievements of human genius. And if that didn't captivate Leopold Bloom, I do not know what did or what wouldn't. We're going to take a trip down now along the corridor, down to the time corridor. And it is from this time corridor that the clocks were set. And time was then relayed on cables down along the Royal Canal to Dublin city centre. These are the very same clocks that would have been ticking at the time when Joyce was writing his books. And these clocks had signals that went along the Royal Canal on a cable, down to Trinity College Dublin for the scientists to set their time, and also to the time ball. And here's a quote from James Joyce: "Time ball on the ballast offices down, Dunsink time. The clock is worked by an electric wire from Dunsink, must go out there." Actually, I must find out if that wire still exists. But the time, every single day, time was set from this, and it went to a ball that hung over Ballast House, just overlooking the Liffey. And at the Liffey, let's turn this back around here so you can see me. There I am now. So we're now in the Meridian Room in Dunsink Observatory. And at the Meridian Room, the ceiling would open up, and then the astronomer would look out and measure the distances of the stars using parallax, which Bloom talked about as he walked along the River Liffey. Now, if you think of, and in it actually struck me that he tried to test out parallax for himself. And he did that by raising his hand up. So I want you all to try this yourselves. Raise up your right hand, as Bloom did, with your little finger proud, just like that. And then close one eye, and then close the other eye, and go back and forth, closing one eye and then the other eye. And you'll see that your finger moves left and right as you blink left and right. Now, if you move your finger closer and move it back and forth, you'll see that your finger moves even more. And that's the principle of parallax. Your finger is further away and it appears to move less. And if it's closer, it moves further. And that's what the principle that was used here to look at the stars. Except the way it was done here was every 6 months you would measure the positions of the stars, and the stars that were closer to us would appear to move relative to the background stars. And with that, you could very accurately measure, using some high school trigonometry, you could then work out the distances to the stars. So what else did I want to say to you about this? So with parallax and with time, and actually there's a lovely proposal at the moment to reinstate the time ball possibly on top of Ballast House. And so wouldn't it be a wonderful connection to recreate, where we have Dunsink time triggering the time ball to fall at 1 o'clock every day. So thank you very much, and I'll pass it back over to our host, and I'd be delighted to take some questions later on. Back over to you, Dervla.
Thank you. Thank you, Peter. That was so beautiful to have a tour of we're missing Dunsink absolutely this evening, so that was wonderful that you could
next
show it.
year I'd be delighted to welcome you all out here for an evening.
Great, wonderful. I'll be there. So next we have up we're very privileged. Oh no, first it's me and Sinead. So this is a recording that we did over the weekend, and it's a piece of music taken from Ulysses that is actually a piece of music set to a Yeats poem. So James Joyce liked to write music as well as be a wonderful singer. And he liked to compose to poetry, but this was very special. This was a piece that he composed and sang to his dying brother, George, and he recreates this scene in Ulysses, where he sings this song to his dying mother. It's, of course, Who Goes with Fergus, and we hope to celebrate Yeats's day as another Dublin writer, even though, of course, his love was in Sligo. So this is Sinead Murphy and myself in the James Joyce Centre singing Who Goes with Fergus.
It's the clock is working.
Or maybe not. I just love that line, all dishevelled wandering stars. It is, of course, the song that Stephen Dedalus sings right at the beginning of Ulysses. So it's the chapter, of course, that most people begin. And even if they never get any further, they might have listened to Stephen Dedalus talk about no more turn aside and brood. So next up, which I thought was next, we are really honoured this year to have Barry McGovern join us. He's actually here, as is Sinead Murphy, who sang so beautifully there. So Barry is with us, and over the weekend he was able to film in the James Joyce Centre the Heaventree of Stars section from the Ithaca episode in in Ulysses, where Stephen, Daedalus, and Leopold Bloom discuss the world and have many questions about the skies and the universe. So if Caoimhe, if you're ready.
What spectacle confronted them when they, first the host, then the guest, emerged silently, doubly dark from obscurity, by a passage from the rear of the house into the penumbra of the garden? The Heaventree of Stars, hung with humid night blue fruit. With what meditations did Bloom accompany his demonstration to his companion of various constellations? Meditations of evolution increasingly vaster, of the moon invisible in incipient lunation, approaching perigee, of the infinite latiginous scintillating uncondensed Milky Way, discernible by daylight by an observer placed at the lower end of a cylindrical vertical shaft 5,000 feet deep, sunk from the surface towards the center of the Earth. Of Sirius, Alpha in Canis Major, 10 light years, 57 billion miles distant, and in volume 900 times the dimension of our planet. Of Arcturus, of the precession of equinoxes, of Orion with belt and sextuple sun, theta and nebula, in which 100 of our solar systems could be contained, of moribund and of nascent new stars such as Nova in 1901, of our system plunging towards the constellation of Hercules, of the parallax or parallactic drift of so-called fixed stars, in reality ever-moving wanderers from immeasurably remote eons to infinitely remote futures, in comparison with which the years 70 of allotted human life formed a parenthesis of infinitesimal brevity. Were there obverse meditations of involution, increasingly less vast? Of the eons of geological periods recorded in the stratifications of the Earth, of the myriad, minute, entomological organic existences concealed in cavities of the Earth, beneath removable stones, in hives and mounds, of microbes, germs, bacteria, bacilli, spermatozoa, of the incalculable trillions of billions of millions of imperceptible molecules contained by cohesion of molecular affinity in a single pinhead, of the universe of human serum constellated with red and white bodies, themselves universes of void space constellated with other bodies, each in continuity its universe of divisible component bodies, of which each was again divisible in divisions of redivisible component bodies, dividends and divisors ever diminishing without actual division, till, if the progress were carried far enough, naught, nowhere was never reached. Why did he not elaborate these calculations to a more precise result? Because some years previously, in 1886, when occupied with the problem of the quadrature of the circle, he had learned of the existence of a number computed to a relative degree of accuracy to be of such magnitude and of so many places, e.g. the 9th power of the 9th power of 9, that the result having been obtained, 33 closely printed volumes of 1,000 pages each of innumerable quires and reams of India paper would have to be requisitioned in order to contain the complete tale of its printed integers of units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions, tens of millions, hundreds of millions, billions, the nucleus of the nebula of every digit of every series containing, succinctly, the potentiality of being raised to the utmost kinetic elaboration of any power of any of its powers. Did he find the problems of the inhabitability of the planets and their satellites by a race given in species, and of the possible social and moral redemption of said race by a redeemer, easier of solution? of a different order of difficulty. Conscious that the human organism, normally capable of sustaining an atmospheric pressure of 19 tons, when elevated to a considerable altitude in the terrestrial atmosphere, suffered with arithmetical progression of intensity, according as the line of demarcation between troposphere and stratosphere was approximated, from nasal hemorrhage, impeded respiration, and vertigo. When proposing this problem for solution, he had conjectured as a working hypothesis, which could not be proved impossible, that a more adaptable and differently anatomically constructed race of beings might subsist otherwise under Martian, Mercurial, Veneral, Jovian, Saturnian, Neptunian, or Uranian sufficient and equivalent conditions, though an apogean humanity of beings created in varying forms with finite differences resulting similar to the whole and to one another would probably, there as here, remain inalterably and inalienably attached to vanities of vanities, and to all that is vanity. And the problem of possible redemption? The minor was proved by the major. Which various features of the constellations were in turn considered? The various colors significant of various degrees of vitality: white, yellow, crimson, vermilion, cinnabar. Their degrees of brilliancy, their magnitudes revealed up to and including the seventh. Their positions: the Wagoner star, Walsingham Way, the Chariot of David, the annular cinctures of Saturn, the condensation of spiral nebulae into suns, the interdependent gyrations of double suns, the independent synchronous discoveries of Galileo, Simon Marius, Piazzi, Leverrier, Herschel, Gala, the systematizations attempted by Bode and Kepler of cubes of distances and squares of times of revolution, the almost infinite compressibility of hirsute comets and their vast elliptical egressive and reentrant orbits from perihelion to aphelion, the sidereal origin of meteoric stones, the Libyan floods on Mars about the period of the birth of the younger astroscopist, the annual recurrence of meteoric showers about the period of the feast of St. Lawrence, Martyr, 10th of August, the monthly recurrence known as the new moon with the old moon in her arms, the posited influence of celestial on human bodies, the appearance of a star, first magnitude, of exceeding brilliancy, dominating by night and day, a new luminous sun generated by the collision and amalgamation in incandescence of two non-luminous ex-suns, about the period of the birth of William Shakespeare over Delta in the recumbrant, never-setting constellation of Cassiopeia, and of a star, second magnitude, of similar origin but of lesser brilliancy, which had appeared in and disappeared from the constellation of the Corona Septentrionalis about the period of the birth of Leopold Bloom, and of other stars of, presumably, similar origin, which had, effectively or presumably, appeared in and disappeared from the constellation of Andromeda about the period of the birth of Stephen Dedalus, and in and from the constellation of Auriga some years after the birth and death of Rudolf Bloom, Jr., and in and from other constellations some years before or after the birth or death of other persons. The attendant phenomena of eclipses, solar and lunar, from immersion to emersion, abatement of wind, transit of shadow, taciturnity of winged creatures, emergence of nocturnal or crepuscular animals, persistence of infernal light, obscurity of terrestrial waters, pallor of human beings. His, Bloom's, logical conclusion, having weighed the matter and allowing for possible error, that it was not a heaven tree, not a heaven grot, not a heaven beast, not a a heaven man, that it was a utopia, there being no known method from the known to the unknown, an infinity of renderable equally finite by the supposititious apposition of one or more bodies, equally of the same and of different magnitudes, a mobility of illusory forms immobilized in space, remobilized in air, a past which possibly had ceased to exist as a present before its probable spectators had entered actual present existence.
That was so wonderful. Hang on. It's a shame you can't hear us all clapping, which I'm sure we are. That was so wonderful. Thank you. I think you might have to be back for next year. Barry was telling me yesterday that he went to school just in Castleknock, but had never been to Dunsink. So definitely now we'll have to get you in for next year. Thank you very much. So next up, we are lucky enough to have the return of Owen Gill from last year. Owen was so busy today that he made a recording for us of his lecture, but he is here this evening to be able to take questions. So this fits very neatly into all that we've just listened to in Barry's reading. Owen, of course, is co-director of CalMast STEM Outreach Centre at the Waterford Institute of Technology and has been coordinator of Maths Week since its foundation in 2006. And of course, I know him as a complete stalwart in creating wonderful science events and creating wonderful outreach, accessible science and maths programs throughout Ireland. So we're very lucky to have him in this country. And we're very lucky to have him here at our event this evening. So Kiva, if you'd like to play our next lecture, thank you.
If the clock is worked by an electric wire from Dunsink, let's go out there some first Saturday of the month. If I could get an introduction to Professor Joly or learn up something about his family, that would do too. Man always feels complimented. Flattery where least expected. Nobleman proud to be descended from some king's mistress, his foremother. Lay it on with a trowel. Captain Han goes through the land. Not go in and blurt what you know you're not to. What's parallax? Show this gentleman the door. Well, I think that's a poignant passage because Bloom is always the outsider, but here he is an outsider to the world of science. Dunsink is remote to him, and further remote is Professor Joly. I'm glad to say that in 116 years things have changed a lot, and Dunsink is accessible to people all over the world tonight, and the Dublin Institute for Advanced Studies has a great programme of public engagement and have been running a great series of lockdown lectures. Now I'd like to look at some of the maths references in the Ithaca chapter of Ulysses. Some of the passages read so well by Barry McGovern. It's such a treat to hear him bring it so alive. And I'm going to pick on a few of those sections and look at them through mathematical eyes. Pythagorean sesquipedalia of the Panepistimion. I'd like to thank Des Gunning for that title and thank him for making me attempt to pronounce it publicly. It comes from Finnegan's Wake, and like a lot from Finnegan's Wake, I find it difficult to understand. The Pythagoreans were a cult that believed in the magic and significance of numbers. Sesquipedalian refers to the use of polysyllabic words, a kind of bombastic or long-winded speech. And Panepistimion refers to a place for all knowledge, which may be a university. So it's an apt title, though, for an investigation into this section of Ithaca, where Joyce and Bloom and the interlocutor have a great fun with very large numbers. the biggest of which is the incalculable trillions of billions of millions of imperceptible molecules contained by cohesion of molecular affinity in a single pinhead. Well, let's look at this. He's talking about trillions. That's 10 to the power of 18 by billions by millions. And that is 10 to the power of 36. So that's a pretty big number. And too big, I'm afraid, for the number of molecules or atoms in a pinhead, which would, for a 1.5 millimeter diameter spherical pinhead, I calculated to be around 10 to the 20, which is a long way off. Had he went for thousands of millions of billions, he would have been pretty much in the right ballpark. But this isn't giving us the final answer, because the next question is, why did he not elaborate these calculations to a more precise result? So maybe he would have checked his figures had he not been learned of the existence of a number computed to a relative degree of accuracy to be of such magnitude and of so many places, e.g. the 9th power of the 9th power of 9, that the results having been obtained, 33 closely printed volumes of 1,000 pages each would be needed to write it all out. And let's look at it here. 9 to the power of 9 to the power of 9. Well, we can calculate 9 to the power of 9 on our calculator easily enough. 9 to the power of 9 is equal to 387,420,489. A big enough number on its own right. Try raising 9 to the power of that, and you'll find that neither your calculator nor your computer will be too obliging. But we can figure out how long such a number is, and we can use logs. So for instance, log of 100, the log to base 10 of 100 is equal to 2. So if we take the log of a number and add 1, we get the number of digits in it. So how to take the log of 9 to the power of that is equal to 397,420,489 times the log of 9, and that will be 369,693,099.63. We add the 1 and we will be 369,693,100, and that tells us the number of digits in this fantastic number of blooms. And if we divide that by the 33 volumes he claims it would require, we will get 11,000, I'll write it up here, 11,202,821 characters per volume, and we have 1,000 pages in each volume, so that would be 11,203. We would need to be able to print 11,203 numbers on each page, and he says it's closely printed. So can we closely print it? Well, we can, yes. This is printed with 8-point font, perfectly legible, small but still legible. And if we do a word count on it using Word, we'll find that we can indeed fit 11,203 words. So it is perfectly possible to contain the number 9 to the power of 9 in 33 volumes of 1,000 pages. So Bloom and Joyce were on solid ground here with this particular claim. Elsewhere In the Ithaca chapter, we learn of Bloom's schemes and dreams to get rich quick. And we'll take a look at a couple of these. A contract with an inconsiderate contractee for delivery of 32 consignments of some given commodity in consideration of cash payment on delivery per delivery at an initial rate of 1/4 pence to be increased constantly in the geometric progression of 2. That is 1/4 pence, half pence, penny, 2 pence, 4 pence, 8 pence, 1 shilling, 4 pence, 2 shilling, 8 pence to 32 terms. Well, we can calculate that reasonably easily, and that will earn Bloom £8,947,848, 10 shillings, 7 3/4 pence. That is assuming he can find somebody with the financial capacity and the lack of mathematical capacity somewhere around Eccles Street to oblige him. Now, he also talks about a prepared scheme based on a study of the laws of probability to break the bank at Monte Carlo, and the solution of the secular problem of the quadrature of the circle, government premium £1 million sterling. Well, unfortunately, the quadrature of the circle is impossible. That is being able to construct a square equal in area to a circle, and there was no government premium anyway of £1 million sterling. But Joyce was able to make fun using maths and science in this episode, and do read it, enjoy the fun he has and the certain cadence and rhythm to the scientific and mathematical language therein. So I'd like to thank the Dublin Institute for Advanced Studies and those organising this event, Darina and Des and Luke, and I'd like also to wish the Dublin Institute for Advanced Studies a very happy 80th birthday.
Fortune smiled upon me as she never Thank you, Sinead, and thank you, Owen. That was really fun, even if my brain is melting trying to work out all that complex maths. I think that's why I got into singing and prancing. Next up, we are delighted to have Luke Drury once again to give us some of his wonderful knowledge. Luke, of course, was former director of Dunsink, and he has just recently been re-elected as board member of ALIA, the Union of All European Academies. He was, of course, president of our Royal Irish Academy from 2011-2014. So welcome everybody to Luke Drury. Thank you.
Well, thank you so much, Darina. I mean, I'm blushing here. It's a great pleasure to take part in this again. I think this is the third or fourth year now. And I would like to pay tribute to Des, who actually came up with this idea and inspired it. So I'd like to share my screen if I can. Let's just try that. Okay, there we go. Yeah. So basically, I just wanted to pick up on some of the astronomical references that were made in the Heaventree of Stars. And this is a rather beautiful print by the British artist Richard Hamilton, which illustrates the Heaventree of Stars. It's not actually terribly accurate, I think, because if you read the text, it's clear that Bloom is actually not asleep, he's stepping outside. But it's a very pretty picture. Oops. So there are lots of a great many astronomical themes referenced in that piece, which was so beautifully read. But I wanted to pick out three. And the one which really attracted my attention, first of all, was this claim about the 5,000 feet shaft and stars being visible in daylight. And then I thought I'd say a little bit about the comment on Sirius, and then a little bit about Nova 1901, which is mentioned. So if you remember, there was that passage of the infinite, latiginous, scintillating, uncondensed Milky Way, discernible by daylight by an observer placed at the lower end of a cylindrical vast shaft, 5,000 feet deep, sunk from the surface towards the center of the Earth. This is actually a very old urban myth in astronomy. And there's a beautiful article by David Hughes from 1983, where he talks about this. It's called On Seeing Stars, Especially Up Chimneys. And if you look at the abstract, he says, the daytime observations of stars from the bottom of chimneys and wells is an old astronomical chestnut. This paper reviews the reports of these legendary occurrences and the attempts made to verify the observations scientifically. After considering the ability of the naked eye to pick out stars against a bright sky background, it is concluded that looking up chimneys is the last thing one should do if one wants to see stars. But it's a very old idea, and it actually goes back to a remark made in passing by Aristotle, who wrote, the man who shades his eye with his hand or looks through a tube will not distinguish any more or less the differences of color, but he will see further. At any rate, people in pits and wells sometimes see the stars. Well, that's the claim. It seems actually pretty implausible. I mean, if you think about it, the sky brightness during the day is such that even if you stop down your field of view to a very small area, the human eye will not be able to see a bright star, except possibly if you're at high altitude, so there's less air for Rayleigh scattering to take place, and you have extremely favorable conditions. There is one report I've been able to find of somebody who claimed that they could see Sirius shortly after sunrise, but that was only because it was directly overhead and they were 1,000 meters up in Zimbabwe. But strangely enough, the idea has been accepted by many people down through the 2,000 years or so since Aristotle first started this rumor. But not everyone was prepared to take Aristotle's word for it. And the great German naturalist and explorer, Alexander von Humboldt, who actually started his life as a mining engineer and an expert on geology. He'd been down a great many mine shafts, and he observed, sorry, I've gone, yeah, sorry, now I'm getting away. While practically engaged in, sorry, I have to hide this thumbnail. Okay, sorry, a bit of my screen was blocked off there. While practically engaged in mining operations, I was in the habit during many years of passing a great part of the day in mines where I could see the sky through deep shafts. Yet I was never able to observe a star, nor did I ever meet any individual in the Mexican, Peruvian, or Siberian mines who had heard of stars being seen by daylight, although in the many latitudes in both hemispheres in which I have visited deep mines, a sufficiently large number of stars must have passed the zenith to have afforded a favorable opportunity of their being seen. This brings us to where did Joyce pick up this idea? And interesting enough, one person who did rather uncritically believe in the story is somebody whose name has come up right at the beginning. The author of many works of popular astronomy, obviously mentioned and undoubtedly read by Joyce, the one-time director of Dunsink Observatory, Sir Robert Ball. After his period as director of Dunsink, he became Lowndean Professor of Astronomy in the University of Cambridge. Somebody has said he was the Brian Cox of his day. He was a very popular writer of popular books on astronomy, of giving popular lectures. And he took this at face value and asserted that a good telescope will always show the stars. And even without a telescope, they can sometimes be seen in daylight in rather an odd way. If you can obtain a glimpse of the blue sky on a fine day from the bottom of a coal pit, stars are often visible. The top of the shaft is, however, generally obstructed by the machinery for hoisting up the coal, but the stars may be seen occasionally through the tall chimney attached to a manufactory when an opportune disuse of the chimney permits of the observation being made. The fact is that the long tube has the effect of completely screening from the eye the direct light of the sun. The eye thus becomes more sensitive, and the feeble light from the stars can make its impression and produce vision. And there's a rather nice picture, which comes from his book, Starland, not the book that we saw at the beginning, claiming or purporting to show how a rather rotund gentleman at the bottom of a chimney can see stars in broad daylight. But of course, it's not true, and it's an interesting example of a great scientist repeating a myth without bothering to check it himself. He should have read Alexander von Humboldt. What about the statement that Sirius is 10 light years distant and 900 times the volume of our planet? Well, the distance he quotes is actually remarkably accurate. It must have been based on parallax measurements, and the modern value is actually 8.6 light years, but the volume is hopelessly wrong. It should actually be something more like 6,400,000 times the volume of our planet. But of course, we have to remember that Joyce was writing way back at the very beginning of the 19th century, the 20th century. And before we had any real understanding of stellar structure, the modern theory of stellar structure had to wait for the development of quantum mechanics. So really all they had were the very first parallax measurements. Even those were really at the limit of what was possible. And it is remarkable that the distance estimate is actually quite accurate. So the main theme, of course, of that whole passage is the vastness of space. And it's worth reflecting, I think, that there was even then, Joyce thought of space and the distances in between the stars as being so large compared to human experience. But in fact, they had no comprehension at that time of how large the universe really is. Our vision has expanded enormously since then. And at that time, people still thought that the spiral galaxy, or as they would then call the spiral nebulae, first seen, of course, in Burr with the Leviathan and Parsonstown, they were still thought to be located with our own galaxy. And the entire universe was thought to be little more than what we now regard as our own galaxy, the Milky Way. The idea that there were other galaxies very much further away, initially called island universes, that came later. And we now know that the universe contains nearly as many galaxies as there are stars in our galaxy, and all those are enormous numbers. Just to finish, Nova 1901. This again shows how accurate Joyce was in many respects. There was indeed a bright nova. The star GK Persei became a white dwarf, and there was a thermonuclear explosion on the surface in 1901, which led to it becoming a very temporarily a quite bright star, magnitude 0.2, so easily visible to the naked eye. And it's left behind this expanding cloud of debris, which we can observe in the picture. It's since been observed, of course, and it seems to have settled down now and become what is called a cataclysmic variable. There's still a little bit of matter being transferred onto it, and every now and then it explodes. So just to wrap up, I think one lesson we can draw from this is that Joyce actually was very well informed about astronomy and its history, presumably from popular accounts such as those of Sir Robert Ball. And in general, as Owen has pointed out in his mathematics, he is remarkably accurate. And for a man who was not a professional scientist, he gets his facts generally very accurate. And any errors there really reflect the state of science at his time, rather than any carelessness on his part. So in conclusion, I'd just like to thank everybody, thank Quiver for setting this up, Darina for being the MC, and I'm happy to take any questions. So thank you.
Thank you so much, Luke. And yes, it's been a really wonderful evening once again. The only downside was that we couldn't all physically be together in Dunsink this evening. But I think it really was a gorgeous energy, and we managed to really keep that alive, the lovely feeling that that happens every year in Dunsink. So I would just like to conclude before we can maybe take some questions, to say thank you to, like Luke says, Des Gunning. It's really his brainchild, this wonderful event. I'd like to thank our performers, Barry McGovern and Sinead Murphy, and to just flag that you can see both Barry and Sinead will be performing extracts from Ulysses as part of an event on Friday evening hosted by the Irish Embassy in Washington. It'll be a shared celebration with the Yates Society and the James Joyce Centre and the Irish Embassy in Washington, hosted by Dan Mulhall, the Irish ambassador. So you can log into that. Might be your next Bloomsday event. And it'll have interesting politicians from the US. At this time, it'll be quite an interesting event. I'd also like to thank our scientists, Luke, Owen and Peter, for enlightening us on so many different aspects. And to Kiva, who had the really hard job of moderating this evening. So thank you from myself, Starina Gallaher and the James Joyce Centre, and of course, happy birthday, DIAS.
Thanks, Starina. Just in relation to questions there is one question there from Senna Malloy. When in 1904 was the eclipse, and what type of eclipse was it? Luke or Peter, I think, would probably be best placed for that one.
Well, let me quickly try and Google it. I must admit I don't know. It's probably. So Peter,
I believe there was a St. Patrick's Day eclipse in 1904, if memory serves me correctly, because it was St. Patrick's Day, so I thought it was quite strange. But there was probably another, and I'm not sure if that was visible from Ireland. But you know, there's numerous solar eclipses every year, so I'm not sure. Maybe Luke has found a Google of that.
I don't know. Can I jump in there? Am I on at the moment? Thank everybody. A couple of years ago, I was given one very simple job to do, which was to take this portrait of William Rowan Hamilton on the wall behind me and present it to Dunsink. But I mislaid it. So the last 2 years that we were up in Dunsink, I couldn't find the darn thing. I did find it today. And rather like a portrait that I was meant to present to Brian McGovern about 30 years ago, this one has now turned up as well. And I look forward to being physically present to hand it over to one of you guys. You'll see that Mr. Rowan Hamilton in the portrait here doesn't look very much like he does behind Peter there in Dunsink. That might give rise to some controversy as to which one is real.
Okay, I just looked it up, and there was an annular solar eclipse on March the 17th, 1904. So Peter is absolutely correct.
As ever, somebody must say, surely.
Yeah.
Yeah. The other one I remember is the one on March the 20th, 2015, which was my birthday.
Okay, well done, guys, and well done, Peter, for getting the 17th of March. Very, very impressive. We do have another question there from Owen, and he's wondering, and this is one for you, Peter, or Luke again, what is the newest and oldest working scientific instrument of today?
Oh, what is the newest? Well, the newest, there are a number of cameras that we installed over the past few years, and they're part of a network called Nematode, and they scan the sky all night, looking for shooting stars and or meteor trails. And when the morning comes along, we can work and we can see if we can see any fireballs or any meteor trails during the night. And actually, it's been really nice at the moment during the lockdown, because there's been very few aircraft and so no contrails visible in the sky. So we've been able to pick up lots of these shooting stars. And actually, I'll post some pictures that I have. The oldest scientific instrument. I would wonder if it is the Grubb telescope. I think it was built in the 1820s. The dome itself was the 1860s, but I'm not oh no, excuse me. I know of a sextant that's from about the 1780s, and I might just go and get it and show it to you.
Okay, well, if you want to go get that, Peter, we'll give you
maybe
a
Luke can add to that if you know of anything.
Leo, I'll come to your question once Peter returns, but Jinan Ashraf is wondering if there is any evidence of Joyce ever having into Dunsink Observatory itself. So I don't know, I'll leave that to the Joyce experts or Luke.
I don't think so, but no, he may have been, but I don't believe so.
I think it's very unlikely. I think his friend Con Curran very possibly was, because Curran had a great interest in cycling and in architecture. So if it was an interesting building that was a pleasant cycle out from Dublin city centre, Con Curran would very likely have gone there. But that Joyce got there, no. There's a myth in Ellman's biography of Joyce. There's a story of Joyce cycling from Dublin to Clifton to see if he could get an interview with Marconi at the Clifton radio station. But that didn't happen. Joyce did actually cycle as far as Uachtarard, 12 miles and back. But even though he could cycle, he wasn't an epic cyclist as Con Curran was. So I would think his knowledge of Dunsink was a second hand from the likes of Con Curran in particular. I see Leo Enright is somewhere in the environment, and lovely to see him there. Leo might have some insight in that. I feel possibly. That's my stab at an answer.
Well, we can actually. Peter has returned, so
I have returned with something that caught my eye, which is a transit book that I had locked away in safekeeping. But this transit book contains. It's from 1793, and this is the work of John Brinkley, who later became Bishop Brinkley. He was the first Astronomer Royal of Ireland. And in this are meticulous records of star positions. So I can see Rigel, Capella, what else do I recognize? Gamma, Peggy, and so on. And signed, actually, that page there is signed by John Brinkley from 1793. So that really is a wonderful record of star positions. And again, Brinkley was very much obsessed with using parallax to measure the distance of the star to the stars, and he quite famously got it very wrong as well, and ended up with a big in an argument with the Astronomer Royal for England at the time. And some say that he went off to become a bishop, possibly because of the humiliation around some of that. But others would say that the salary was better than being a bishop than an astronomer. So the truth may be somewhere in between.
Yeah.
Very good. Nice little anecdote
it's
there.
important because he introduced some of the more modern methods of data reduction. He was one of the pioneers in using least squares reduction, I think.
Yes.
Okay. So that brings me back to Leo Enright's question. Peter, he was wondering if you know anything more about the proposal to restore the Ballast House Ball.
Oh, I spotted it in the newspaper, in the Irish Times, I think it was, about 5 years ago, that a developer had proposed, and I think sought planning permission, to place a brass or a copper ball on Ballast House, which would just be so amazing to see again. And I wonder if it was like the Cleary's clock of its time, where people may have met under the ballast ball, or were Dubliners completely unaware of this metal ball that fell every day. But you know, it's funny, if you go to Greenwich, there is a ball as well, but it's no longer shiny, and so it's not ideal for being seen from great distances. But so it would be wonderful to see, but I'm not sure where it is now.
I think that building has been actually redeveloped since, or at least renovated. We have another question here from Senan Maloney, He was wondering if there was something particular about the latitude of Dunsink that made it suitable as an observatory.
Oh, not particularly. When they were doing surveys, the first astronomer appointed by, well, the observatory and the first astronomer was funded by money left by Provost Andrews, and his first job was to go and find a location for the observatory. So they went down to Wicklow, they went out to Howth, which was a difficult job in those days when roads were poor and you were on horseback or in a carriage. At around that time in the 1780s, the Royal Canal was being constructed out through West Dublin. And so I think it's no coincidence that Dunsink ended up on a mound that was easily accessible along the canal. And it's at an altitude of 80 meters above sea level and had beautiful views. And if you right out across the city, even today, there is a comment somewhere of being able to see whales from Dunsink, but I really think that's a little bit of fantasy, to be perfectly honest with you.
If I can come in, Usher was quite explicit. He knew from the work of Maskelyne that if he was too close to the Wicklow Mountains, the vertical pendulum, the plumb line, mightn't actually indicate a true vertical because it would be attracted by the gravitational pull of the mountains. So he wanted to be away from the Wicklow Mountains. Even in those days, there would have been a lot of smoke and pollution from fires in Dublin. So he needed to be to the west of the city so that smoke would be blown away. And Dunsink was the highest point you could find, which was to the northwest of Dublin and which was easily reachable from Trinity. So it was a logical choice, yeah.
He wasn't a fan of Howth either because of the marine and the weather. And so he didn't think that. Although I think Dunsink may have been more popular if it was in Howth than in Dunsink.
I think that's probably true.
I shouldn't say that.
We'll edit that bit out later, Peter. It's okay. Okay, well, that seems to be all the questions on this side. So, Darina, are you still there?
Yes, I am. Yeah. So do you think we've just had a wonderful evening? Thank you all so much. And the comments that everybody has been enlightened and informed. And I think, forget about Howth. I think Dunsink, we're making Dunsink really popular. Look, you've got, packed house tonight from all over the world. So you're just going to have to open your doors to all these wonderful visitors.
Absolutely.
From everywhere, from Boston to everywhere. Thank you.